Hi, and a very good evening to our lecturer, Mr. Pau. I am Muhammad Asad Suhail bin Muhammad Yassin, a group leader for this group. So, without further delay, I would like to pass it to my other team members for the presentation of their part. Thank you very much.
Okay, good morning, Mr. Pao. My name is Onjie, and today I will present about the round robin for the two questions. Okay, for the question one, the quantum is equal to 3. And then, and then we will start with B6 because the B6 arrive time is equal to 0. Next, because the quantum is 3, so B6 will work in 3 seconds. And when the 3 seconds, B4 and B5 already arrived. But B4 and B5 got the same birth time, so we want to choose the smaller priority. So there is the B4, and there will be B5. And then B6, B3, B2, B1, B5, B3, B2, and B1, B1, B1. So for the last, why I will replace 3 times the B1 is because the quantum is equal to 3. The burst time for B1 already more than 3, so we need to repeat B1 more time. Okay, the next I will present about the waiting time. So for the example, B1 is processed at 17 and arrive time is 9, so we use the 17 minus 9. And then because the B1 we process 2 times, so we want to use the 26 minus the 20, so we will get the waiting time 14. And then step by step from B1 until B6, and then we total up, and we can count the average waiting time just using the total minus the number of process, so we will get 11.33. Okay, now I will pass to Chihan.
Hi sir, my name is Tan Jihan. In this video, I would like to share about the scheduling algorithm, and this is our question for this project. And now we will start from the preemptive shorter job first. Now, we will need to know which process we will start from we need to start from which process, and we choose the B6 because the B6 has the 0-second arrival time, because every process need to start from the 0 second. In 0 second there's no another process that's coming in, only the B6 only, so we just choose for this. After that, we will run until 3rd second, because the 3rd second got another process that's coming in. That is B4 and B5, so we need to stop at the 3rd second and continue to run the B6 until it is finished, until 4th second, because 4th second still have the another process, but the B6 only 4 burst time, so already finished. So we need to choose the next process, which is B4 and B5, because there is same burst time and arrival time, so we need to look at the priority. The B4 has the highest priority than B5, so we need to run B4 first. Run until 7 second, because the arrival time is 7 second, got one process. After that is run until 8 second, because the burst time for B4 only left 1 only, so we run until 8. And now we going to next process, which is B5. There's 4 burst time, and then we need to stop at the 9 second, so we run until 9. So now we left 3 burst time, then we run until finish, because there is no another process coming here, so just run until finish. And then it's B3, the burst time is 5, B2 6, B1 10. Okay, and then is waiting time. The waiting time is using the starting time minus the arrival time, so we can know B1 start from 33 second and minus the 9 arrival time, like example lah. And the last we will calculate until the 38. This is some error. Okay, so then we use the 38 divide 6 can get the 6.33 ms. This is the various waiting time. And then we going to next question, non-preemptive shorter job first. In this process is similar as the preemptive shorter job first. Now we will start from 0 first also, and then we no need to stop at the 3rd second, we just directly run until 4 seconds, then finish the first process. Because there is no non-preemptive, so no need to care about the arrival time. And then the burst time next process is B4, 4 second, highest priority. B5, burst time is 4, and then the arrival time is 3. B3, 5 second. B2, 6 second. B1, 10 second. And the waiting time is same formula as this. Got some problem here. Okay, finish. So this is the same formula with this. And then we will go to the next question, the preemptive priority. In this method, we need to take care about the priority first. So we will do it first. Okay. Every process starts from 0. B6 will be the in front until 3rd second. And then we need to look at the 3rd second. Got 2 process, which is B4 and B5. But B4 has the highest priority than the B6. So we will run B4 until the next arrival time. And now our process is B4. So we can look at the 4 second. B3, the priority is 3. It's below than B4, so continue run B4 at the 7 second. B2, priority is below than B4, but B4 already finished, so we don't need to care about this already, the B4. We need to choose the next process, which is the priority lowest than B4, only 1, like this, 1, 2. Then now we need to know B2 and B6 which has because they has the same priority, so we need to know which has the lowest burst time. We need to know which can more faster, so we look at this. B6 has the lowest burst time than B2, so we continue run B6 until finish at the X second. And then it's B2, the priority level 2, and run until 9 seconds. And the 9 second priority is 5, below than B2, so continue run B2 until finish, because after 9 seconds there's no process coming in. Okay. And then B3, the 3rd priority, finish, no 4, so we continue 5, B1, B5, 6. Okay, then we can check the answer from this. If the answer, we calculate the burst time total, is become the 33. Same with all. Okay. And the waiting time is got something different. We need to know about this. Nothing. Here. B6, because the B6 got 2 process at different time. First process is start from 0, but the second process is start from 7 seconds. So we need to use the B6 after the running time, the 3rd second. We're using the 7 minus the 3rd, can get the duration between B4 and between here, the waiting time. So we can get the answer 51 after total all B1 until B6. And then we divide 6, we'll get the 8.5 ms. Okay, now we're going to next question, non-preemptive priority. This is more easier than the preemptive priority because there is no more the new process arrive. So we will look at this here, start from B6, the 0, run until finish 0 to 6, 0 to 4 until finish, and then we need to choose the next process at the before 4 second. Before 4 second got 3 process, which B3 until B5. The B4 has the highest priority because it 1, so run the B4 directly until finish. X second, then in X second we got many choice, it from B2 until B4, not B5, B2 3 5, and then 2 3 5. B2 has the highest priority than another 2, so B2 will be next process, and then is 14 second. Okay, both more than 9 already, no need to care about the rest time already. B3, because the B3 is third priority, and then is B1 5, B5 6. Okay, this is same, the formula also is same with the shorter job first, no need to care about the duration like this, so we can get different answer from these two, and the last answer will be X millisecond. Okay, that's all my presentation. Thank you.
Okay, now turn back to me. So the question 2 is more easier with the question 1. And then question 2 will be the quantum equal to 5. Okay, for the first, we also choose that who is the arrive time equal to 0. That is the D4. And then because the D4 not got the enough burst time to run the quantum equal to 5, so we just using 3 seconds. And then next will be D2 is because when the time in the first second, D2 already arrived. But D2 also not got enough burst time, so we also just using the 4 seconds, so it will be 7. And then next will be 1, D5, D6, D3, D1, and D3. And next is the question 2 waiting time, so just the example D1, because the D1 will process at 7, and arrive time is 2, so 7 minutes 2. Also the D1 will be processed in 2 time, so 27 minus 12, and we will get 20. And then for the others, D1 until D6, use the same method, we can get the answer and we total up. Want to count the average waiting time, maybe just using the total divide by 6, we'll get 9.83. That's all for my presentation. I will pass to the Akmal.
Hello Mr. Pau, my name is Akmal Mukri Bainuddin, and for my part, I'm going to explain about the question 2B and C. So for question 2B, which is the preemptive SJF or shortest job finish, by the name, we would know that the type of calculation is we are going to take the earliest arrival time and the lowest burst time as the first process that needs to be finished. So as an example, for my calculation, as you can see here, the D4 came first as the first process that needs to be done. So we are going to put it here. And by the time of 1, there is a new process that came in, which is the D2. But because we already have the D4, so we need to finish it, and then we would insert the new process. So this circle of process will go on until one process is finished. So as you can see, I did a new column until the first process, which is the D4, is finished, and then I insert the new process, and it goes on until the last process, which is the D3. So for the waiting time, how do we calculate this? Is by we take the time that the process arrived minus to supposedly their arrival time. as you can as you can see here, for D1 it arrives at the time of 17, but it supposedly be in the calculation or in the table at the time of 2. So we minus that and we will get the numbers. So we repeat the calculation for each process, and then after we get the numbers, we total it, and we will insert it by divide it to 6 to get the average waiting time. So for question 2b, the average waiting time is 7.5 milliseconds. Hello Mr. Pau. So for question 2c, we are going to solve the question using the non-preemptive SJF method. So the difference between preemptive SJF and non-preemptive SJF is, for non-preemptive SJF, we are going to solve every process one by one. So it's a lot easier compared to the preemptive SJF. So as you can see here, at the time of 0, the first process, which is the D4, comes in. And compared to the preemptive SJF, every time a new process comes in, we need to do a new column. So for non-preemptive SJF, we don't have to do a new column. We just need to finish the process until the burst time is done, and then we proceed to the next process. So as you can see here, the D4 comes in first, so we settle it until it's done, and then the next process, which is the D2, comes in, and the flow goes on until the last process, which is the D3. So for the waiting time, the calculation is simply the same, which is you took the process arrival time minus to the supposedly the time of their arrival, which is, as you can see here, D1, it arrives at the time of 17, and supposedly it needs to be in the table at the time of 2. So we minus that, and then we get the numbers. And then all the numbers here, after we done the calculation, we are going to divide by 6 to get the average waiting time. So that's all from me. Thank you very much.
Thanks to my other team members for your presentations. Now I'm going to present of my part, which will be the last presentation of our group presentation. So without further delay, I would like to present my part, which will be the primitive priority and non-primitive priority. So I move to primitive priority first. So for the primitive priority, we must look to the fastest burst time, arrival time, and priority. In case if the priority is more than the upcoming or previous priority, then we need to take that. But we must also look to the arrival time and burst time before we take that process. In case if the burst time or arrival time is same or either priority is same, either one of these will be different. So we need to look for the differences, and then we need to decide which process we need to execute first, like this, just like this. I did here. Then after we already done here, then we need to calculate the waiting time, which will be we need to take from the process that we did on the table. For every table, the process we need to start from 0, like I did here. Okay. After that, we need to calculate waiting time, just like this. We need to calculate the waiting time, and the total of that process need to be minus with the arrival time, just like this. For D1, we need to minus 3. We need to take 3 to be minus with 2, take 3 from here to be minus with 2, and same for the D2. We need to take the D2 process from here 9, and we need to minus with the arrival time of D2, that is 1. Then we will get the answer. Then after that, we need to uh, add and plus all. After we already get the total of this, we need to add and plus all of the answers here to get the total. we need to plus 1 plus 8 plus 16 plus 8 plus 10 plus 14, and we will get the answer. And for the finally, we need to calculate the average waiting time, which we need to take this a total of this to be divided with 6, like this. 57 divided with 6 will be 9.5 milliseconds. So now I will move to non-primitive priority. So for the non-primitive priority, you just need to take the fastest priority, the first come first serve priority. Which one will be the first priority? Which one will be the second? So for this, we also need to start from 0. For this table, we also need to start from 0. So for the 0 is D4. So we need to execute D4 first, just like this. We need to execute D4 first because it is 0. So we need to execute D4 first, then we need to see which one will be the second priority. So what we know is on the table, D1 will be the first priority, so we need to execute D1 first, and D2 will be the third priority, so we need to execute D2 first. For D5 and D6, the priority is same, but we need to look for the arrival time for D5 and D6. Which one is the shortest arrival time? So D5 is the shortest arrival time, and we need to execute D5, and next to others is the same. It is applied to others same as well, and we need to execute D6 and lastly D3, because the priority of D3 is the last one. Priority of D3 is 5. That's why the D3 will be on last. So we just need to take the burst time and plus with the burst time to get the total. So after that, we need to calculate the waiting time, which we need to do it like this as usual. So we need to take like this 3 minus with 2, the total of process D1. We need to take 3 to be minus with the arrival time of D1, that is 2 will be equal to 1, and same applies to D2, D3, D4, D5, and D6, and we will get the total. And after we get the total, we need to plus all the total for the process to get the answer for the whole waiting time. To get the answer for the total waiting time, like this, we need to plus 1 plus with 8 plus with 16 plus with 0 plus with 10 and plus with 14, we'll get 49. And finally, just like as usual, we need to calculate the average waiting time, which will be 49 divided by 6. 49 will be divided with 6, and the answer will be 8.2 milliseconds. That's all for our group presentation. Thank you very much.